So yeah, I'm Nick Martin, senior consultant here. I was on this project for the first couple phases. It's been extended to do some performance enhancement stuff. I haven't been involved with that, but Vince will talk about that. So for the agenda today, we're going to start with a little bit of background. What is the Internet of Things? What's the business problem that we were trying to address? What was the old architecture we started with? What's the new architecture we went to? We'll talk about some performance and load testing that we did to vet the system, and we'll reveal some of the lessons learned that we had just over the course of the project, and then finish off with talking about some kind of next generation where we think this project might go in the future. So what is the Internet of Things? What are we talking about here? So does anyone have one of these devices or know what that is?
Finally,
we actually have quite a few people in the back there. That's great.
We've done this presentation for many unhealthy people so far, so good.
This is the best group. So that's a Fitbit. It's a personal pedometer. It's an activity monitor, and it captures information about the way you live, right? So how active you are, how you sleep, things like that. This is a Nest thermostat, which that's a drawing, right?
Yeah.
So that's going to be our drawing later today. I had to confirm that. So that's pretty cool. It's a thermostat, internet enabled. So from anywhere in the world, you can set the temperature of your house. You can check what the temperature is, all that kind of stuff. Internet of Things. How about this? Who can identify what that thing is? What's that? It looks like a sump pump. That is the most common answer, but that's actually a seismometer. And that's actually big business here in Ohio. So there's the fracking industry we know is pretty big. And there's a big array of those guys scattered all over the state, monitoring all those like micro quakes and things like that. That device needs to get its data somewhere, make use of it to evaluate the data and get metrics, and it does that over the internet. Here's another example. This is an ocean buoy. And up on this mast, there's probably 15, 20 different sensors capturing who knows what data, and all of it, again, sent over the internet. So what's common about all these devices is that they communicate over the internet. They tend to be kind of specialized in what they do. They're monitors, sensors, they capture very specific pieces of information. But kind of the more important thing about all these things is that they're ubiquitous, and they're becoming more and more ubiquitous. So Gartner issued a report saying that there are going to be, by 2020, 26 billion non-traditional compute devices like these things here in the market. And Cisco kind of went a little bit broader with their metric. Overall, internet and connected devices, there's going to be 50 billion of them in that same time frame. And all those devices are going to add up to 14.4 trillion with the T dollars industry. So as technology professionals, architects, engineers, it's really important for us to start thinking about how we're going to build the systems that are going to cope with that much data, that much volume of information.
So at its heart, as I said, this presentation is largely a story about a project. Now we've done multiple IoT projects, but this one in particular has an interesting before and after scenario, and generally a good story with it, some good lessons learned as well. So what is this talking about? Now, first of all, we are under NDA on this one, so I can't tell you who this is or exactly what they do, but I can frame it pretty darn well. You'll get the general idea. Basically what it's talking about is compliance tracking. So how does compliance tracking work? If you're compliant, all's good. If you're not compliant, you get slapped around. And in this case, you get some significant financial penalties. So our client sells this as a product to their customers who need to be compliant. And if they're not compliant, they get fined big time. So they want to avoid those fines. So I can't give you the exact details, but I'll talk about this in somewhat, I'll put some concrete terms around it. So this is compliance, and let's say you're all from different companies, and your companies do business with the feds. And the feds have had some problems with security. And they've gone around to your different companies and they walk around the place and they see all your desktops sitting there unlocked with all sorts of people walking around who could just log onto your computer and get in and hack away. Shame on you. So the feds decided, we're going to fine you guys if you don't be compliant, if you don't lock your daggone computers when you walk away from them. Who all locks your computers when you walk away from them? Yeah, okay. The feds don't think so. So let's say you live in cube land, and they can put a sensor in the entrance to your cube that detects when you go in and out. And then they can put a little sensor, or maybe not a sensor, but something on your computer to detect when you log in and log out. So that if you walk out of your cube and you've not locked your computer, you are out of compliance. So your companies want to track you to make sure you're being compliant so they don't get fined. Okay, so our company helps your company be compliant. That's the general theme behind this. And we'll get into details as far as sensors and all that kind of stuff. So there are devices that track physically ins and outs and track whether you're doing things that are compliant. There's also, it's kind of funny, our clients' customers, in general, their compliance, you would think, given they want to avoid all these fines, that their compliance has got to be, you know, pretty high, so they want to avoid those fines. Their average compliance is on the order of around 20 to 30% compliant. So fine. That's what they're dealing with. They have supplemented this with a mobile app so they can physically walk up and look around and see what's going on and say, yeah, compliant, no, not compliant, and keep track that way. When they have their own people go use that mobile app and watch their peers, compliance just shoots up like crazy. We're 70, 80% compliant. When our clients, independent observers, go in there with the same mobile app, what do you think their compliance is? 20 to 30%. So they do have compliance problems here. So that's the overall story, and we'll get into a lot of details later on. From a functionality standpoint, then they don't just collect this data and do nothing with it. Same as all your apps. They collect that data and then they need to look at it and review it and understand what's going on, see how compliant they are. So there's a web portal they can log into and see how they're doing. There's different slices through the web portal. There's administrative stuff, so they can go set up what their facilities are. They can set up their devices, their users, all that kind of typical admin stuff. There's some dashboards so that when they log in first thing, they can see right off the bat, okay, here's some high-level views of how we're doing. Here's how our devices are tracking. Here's our overall compliance. Just a quick, key performance indicators. And then there's some detailed reports. And they can go run and slice and dice their data in lots of different ways, including the typical, can you just export it so I'll go to Excel and that thing too. Everyone's favorite reporting system. Okay, so that's kind of the background. Now, from a devices standpoint, I talked about devices tracking ins and outs and devices tracking, whether you're compliant. So we have sensors to track those two different types, the ones for ins and outs and the ones to track compliance. And then the sensors by themselves don't connect directly to the internet. And there's a reason for that, because to connect to the internet, they need to configure these gateway devices. And the gateway devices, those have a direct connection. They actually post data to an IP address. They have to configure those devices, and that's a bit of a pain to configure those. So they don't want to have to do that a lot. So they kind of minimize the number of gateways, and they have all the sensors talk to the gateway, and the gateway sends the data up. Now let's say we're on a big floor like this, and we have a sensor over that door, a sensor over that door, and all your cubes and whatever. And then there's a gateway, I don't know, way over on the corner of the building where there's a good signal. That's how gateways work, right? How do you get the signal all the way over there to that gateway? You don't want to put a lot of gateways around. So what they use as intermediaries are repeaters. So there's also repeaters to pass the signal along. Okay, so sensors for ins and outs, sensors for compliance, gateways, and repeaters. That's the whole hardware story behind this.
Okay, so before I get into the old architecture we started with, I do just want to say that this architecture works for all intents and purposes. It's still in place. They have some existing customers that are staying on the old architecture, and then any new client implementations are coming onto the new architecture. So just keep that in mind. This is a working solution. And the old architecture was really largely just 2 virtual machines hosted in Azure Amazon Web Services. Yeah, Amazon Web Services. So the first VM was just hosting that portal website that Vince talked about. So that was their dashboards, their reports, the administration, configuration, things like that. And due to some kind of architectural programming decisions in that application, it's not really horizontally scalable. So horizontally scalable, actually, can anyone identify what that is? Define that?
Oh.
No? Okay, so if you scale horizontally, it basically means you're adding new instances. You're provisioning new instances running that application. So there were some issues with that portal that if you have 2 instances of that site up, they would conflict with each other. They just wouldn't work. We certainly could have solved that problem, but there were other problems with that site, and performance was just really nightmarish. In fact, it was so bad that the client was fearful of selling their product to new customers and getting them onto the portal because they thought it would just bring it down and all their other customers would suffer. So that was a really bad place to be. The second virtual machine is kind of what I call the processing VM, and it's made up of 4 main components. So there's the gateway server, which is the component that the gateway devices actually communicated to. So it's basically just a TCP listener. It takes messages from the devices and puts them on a queue. That queue, in this case, was RabbitMQ. So RabbitMQ server was installed on that VM as well, which RabbitMQ is a great queuing technology. It's actually really, really nice. But being on this one VM instance means that the queue depth is limited to the physical resources of that VM, right? So that was another problem we had to tackle. The message processor was kind of the workhorse of this whole thing. It took messages off the queue, did some database lookups, transformed the data, processed it, and then ultimately put it away into the database. And again, just like the website, and due to kind of the message protocols, which we may or may not get to later on, the message processor also could not run in parallel. You couldn't have horizontal scaling, you couldn't have multiple instances of it. So you had one instance of the message processor just dying trying to keep up with the queue. Elastic IP was a feature. It's an Amazon feature that allows us to essentially lock an IP address to a virtual machine. So those gateway devices talk to a specific IP. There's no TCP, it's not enabled. Or I'm sorry, yeah. What can I say? DNS, thank you. DNS isn't supported by the gateway devices, so they had to talk to a specific IP address. And actually that's why the existing customers are still pointing to the old system, because for them to update it to the new system, they'd have to go and reconfigure manually, physically, all of those gateway devices to point to the new system. So Elastic IP kind of solved that problem. For those of you who are, actually, can I see a show of hands? How many of you are working in the cloud or have anything in the cloud? That's
Good.
a pretty decent amount, yeah, that's great. So as you probably know, or you may not know, if you deprovision, which means you shut down, take offline a virtual machine, the next time you bring it up, chances are it's going to have a new IP address. Elastic IP takes care of that. And the last component there is the Amazon RDS, that's the relational database service, and that was hosting a MySQL database. So that was kind of the one platform as a service kind of thing here. So, picture's worth 1,000 words, so I want to see a diagram of this stuff. That's what it looks like. Not very informative, I have another diagram. So this top node here is kind of an abstraction of the diagram, the hardware diagram that Vince showed you earlier. And the big takeaway from this diagram are these kind of orange borders here. Those are the virtual machines, and they are single instance, right? So everything contained within that VM, based on how it was architected initially, was all architected to sit together on one VM, and you couldn't scale it out. So their choices, in order to support more customers and bigger volume of data, was limited really to just try and scale up. And you can scale up to a point until your cloud provider doesn't offer a box bigger than the one you already had. So that's really what they ran into.
So this is the beautiful new architecture. Old, new. Wouldn't you hate to be in the situation where you have a product that you want to sell and you're afraid to sell it? So that sucks. But that's really where they were. So our client went and did some research. They wanted to know, how are you supposed to do these cloud apps? How are you supposed to make them so they can scale and support lots of customers so they could sell this over and over and over again? Seems perfectly reasonable. They talk about the cloud being this massively scalable engine out there. You can do all sorts of big things. But they found out the hard way, it's not always the case if you design your apps wrong. So they needed a redo. Got to get rid of the old team and let's bring in the new team. They did their research, and in their research, they found this new thing called Platform as a Service. Anyone know what that is? Yeah, nods, but no words. Okay, what's Platform as a Service?
So you can basically just spin up your entire platform via an API?
Yeah, so you stand up all the infrastructure and you just put your app on top of that. And in particular, there's services they make available to you in the cloud, and you can just use those services. Like that Amazon RDS, that relational database, that's database as a service. Nice stuff. Makes it very easy to compose apps on top of those services. That platform as a service approach, they thought would really ease some of the pains they had experienced before, and we'll talk about those pains even more as we go into details. In addition to looking into PaaS, Platform as a Service, they learned that Microsoft had invested a lot of effort into coming up with a pretty innovative PaaS system in their cloud, Azure. And they were a Microsoft partner, had an enterprise agreement with Microsoft, so they decided, hey, let's go check out this Azure cloud and see what it can do. So they met with Microsoft, things worked out well, Microsoft brought them to us, and we engaged them to do this new project. So here's the new slice of what this new architecture looks like. There's PaaS at the top, that's Platform as a Service. Down at the bottom you see IaaS, that's Infrastructure as a Service. Infrastructure as a Service is what the old Amazon architecture looked like. They had these VMs. And with those VMs, they can scale them up into bigger and bigger boxes, bigger hardware. But number one, you can only scale so high that way. The boxes only get so big. And as you get bigger and bigger, they get a lot more expensive. So they were paying a lot of money to host this app in the cloud that was not performing. It's a terrible situation. So this slide essentially reverses the situation you saw before. You see, what, 5 things up under PaaS and only 1 thing under IaaS. So let's start at the top, the portal website. That's now hosted in Azure as a Platform as a Service offering on their websites service. Below that, you see the storage queue. So that's using their storage service, which is very cheap storage, but very fast and massive. So they had RabbitMQ, which was kind of limited in its performance and scalability by the size of the VM that it was on. This is a service totally independent of whatever other components we use, and it's massive, and it's really fast and cheap, so you can't get any better. Next up, Nick talked about the message processor. That's the real workhorse. I mentioned it very early on. We needed to pump massive volumes of events. You go in and out, you do something compliant or not, every one of those gets sent up from all those devices to our gateway server, to our event processor, and that really needs to pump data through. We hosted those within Azure and Platform as a Service on what they call web jobs. And web jobs essentially run in the same process as the website. So from our standpoint, it's very easy to do that. Again, platform as a service. Our database, we use Azure's SQL database. Once again, database as a service. On all these things, I will tell you they're all redundant except for that database. So we'll get there. And then finally, there's reserved IP under PaaS, and that's the same thing as Elastic IP. It just gives you that static IP address that never changes. It's always yours. Finally, on the bottom, there's these gateway server VMs, 2 of them. On the old one, they had one box that had a gateway server hosted with several other things. When we got their gateway server code, it was this Java app, and it worked. And with just a couple of very minor tweaks, we could just deploy it. And actually, this was Nick's task, and he was like, I don't really need to rewrite this thing. I could, but it'd take a lot of time. So let's just host it and get it done with. So we put it in 2 very cheap, small VMs. This app is teeny. All it does is receive a message over the internet and write it to a queue. Done. Very simple, high throughput, no problem. 2 very cheap VMs and we're done. Move on. So that's why we have those under infrastructure as a service. Now let's map those over to a diagram. There's the old one on the left, the new one on the right. So you see the gateway server up at the top. That's that little app in a VM. But you notice there's one minor difference. If you look at the box around here, there's multiple boxes. It's implying we could scale out to have more instances of that if we needed higher throughput through that gateway server. We have not needed to yet, but we could. There's the storage queue that the gateway server writes its data to. And that, again, massive volume, very high throughput. Here is the website, which hosts both the website itself and the message processor, all within one process. And we can scale that horizontally to many more instances as we want. In production right now, we just have 3 medium-sized instances and no problem. And finally, on the bottom, there's a SQL database. I mentioned that one is a single instance. That's the only piece here that is a single instance. When we've told the client, look, you really should do some replication here and some redundancy for failover purposes, they've chosen not to do that yet. Okay, it's their decision. So, onward.
Okay, so we've kind of looked in detail at the old architecture and the new architecture. So let's take a step back and kind of look at some of the high-level metrics that we wanted to measure ourselves against. So in terms of overall architecture, the old system was very IaaS heavy, right? It was just on these VMs. The new architecture, we really wanted to take kind of a hybrid approach. So Vince may have mentioned that the client had a preference for PaaS, platform as a service. So wherever we could, wherever it made sense, we moved over to PaaS. But when it made sense to stay in IaaS, we did that. So we kind of leveraged the Azure ecosystem to use the service that makes the most sense. In terms of cost, the old architecture had those 2 VMs that were, the biggest VMs basically you can provision, and it was really, really costly. The new architecture, we have kind of a collection of more PaaS-y kind of services. We can scale them kind of more strategically. Like those gateway servers, they don't need big processing. They don't need anything large. So just put them on the smallest VMs. So we had a lot of cost efficiency on the new system. Scalability was probably the biggest thing that we had to contend with and solve. The old architecture, you could scale vertically, right? Get bigger boxes. On the new system, we can scale both vertically and horizontally. So we can put the services on bigger boxes, or we can just get more boxes. And of course, we have flexibility to, some services we can go bigger, other services we can scale out. We can kind of play with those, we can tune those things, which we'll talk about later. And now we're not 100% there yet on the scalability story, as Vince mentioned with the database. It'd be nice to get some replication, failover, and things like that. The last metric here we haven't really talked about, that's visibility. So on the old architecture, when something went catastrophically wrong, let's say the queue depth in the VM ran out of space, or got too full. It just ran out of space. The only way the client really was aware of that is that customers were no longer getting data in the reports, which is terrible. So with the new architecture, with the new design of the software, we have a lot of diagnostics that we're capturing, a lot of error handling, and kind of a good story for switching over to PaaS services is that now every component is visible in the Azure Management Portal. They can see if it's running, they can see how many instances there are, they can stop it, they can start it, they can really kind of own those services versus we're just going to dump all these things in this VM. And the client didn't really have an IT team to manage these VMs, so they were kind of at the mercy of their vendor that built this thing for them. They're a lot more empowered now. They have more visibility into this stuff.
Performance and load testing. So the fundamental problem that brought us into this story was the fact that performance was horrible, even though it was in the cloud, big, and all that good stuff. So we wanted to make sure if we were rewriting this thing that it actually did perform and meet their expectations. So met with them, talked about, how many customers do you think you're going to have in 6 months, a year from now? What are they going to be doing? Let's put a profile together of what kind of performance what kind of expectations you have. So things like, we want all of our pages to return in less than 5 seconds. Okay, we can measure that. We want to be able to process so many events per hour. Well, we couldn't quite squeeze that metric out of them, unfortunately. But we tried to get some performance expectations and then actually verify that we met those. So 2 sides to the coin here. There's the web portal, so we want to make sure it's responsive and meets those 5-second page times. And then there's the event processor. How many events can we handle per minute or per hour or whatever? Portal side, we're a .NET shop. I'm a .NET developer. I use Visual Studio. And within Visual Studio, I can create web performance tests. I can record and walk through the site and do something, record that, and then it'll save that and build a test out of that. And then I can run that again and again and again really fast and kind of hit the website really hard. What I did was I recorded several scenarios that I talked through with our user. So let's run this report and we'll run it through these scenarios. And let's run this report and these scenarios. Let's hit that dashboard. Let's do some admin stuff. Several different scenarios. Ended up with around, 10 to 12, something like that. And made sure in every case to hit lots of data. So really hit that website hard. And then I could group all those tests together in what's called a load test. And I could just smack the server, hit it hard, log in with 50 concurrent users, all running these requests randomly in sequence. And it looks, I actually have it open here. This is what a load test looks like. So here's all of the different scenarios I'm doing. I'm doing this one 20% of the time, this one only 5% of the time. I just group those together. And I put other things in here like how many users I want and how much time between each request, because users don't run a report and then immediately run the report again unless it doesn't respond and they keep clicking. They don't do that on our side, of course. So that's what the actual test itself looks like. And then here's what the output might look like from one of these tests. So basically information overload, but where we wanted to go with this was to look at a simple table of page response times down here, and we can see here's the average response time, the minimum, the maximum, just statistics crazy. So that's the kind of load testing we did, and I ran these tests and basically in the first few runs found some pages that were kind of like our worst performers, of course, and then let's target those. The surprise in all this was one of our worst performers was our login page. Who would have thought? But it turns out our login page loaded up this pretty complex user profile, and every time it queried for that complex profile. So we put some stuff in place to cache data and make that much more efficient. So that's basically the portal side. Loaded up and made sure we met their performance expectations there. There are also some reports we had to tune, convert to stored procedures, things like that. On the message processing side of things, We got from our client the source code for a simulator. And the simulator would basically sit there and just throw events up to our gateway server to put on the queue. So we could run this simulator and just throw hundreds of thousands of messages on the queue ready to be processed. And then we would switch on our message processor and watch and count how many messages could it process. And we were getting around 20,000 per hour. Now, as I hinted at just a minute ago, we didn't actually have any metrics from them on what they expected as far as throughput goes. They didn't have the information for us. So basically, we went into beta somewhat unaware of what the expectations really would be, but in fact, it turned out to be just fine, and it's still performing just fine to this day, I don't know, a few months after that. Yeah?
How many things in the Internet of Things were you guys able to handle?
Good question. At that time, early on, probably, I think as low as maybe 250 early on, something like that.
250 to 300.
And then,
Second?
what's that?
250 devices total?
Devices.
Yeah, so like for that beta phase. And now they just added another 380 today. It was a surprise. Hey, we just installed another 380 devices. They didn't even tell us. But it's working. Now they're probably over 2,000 or so. Something like that. I didn't check after because they keep surprising us. New installations. This is where we have spent, and we'll talk about this, a lot of effort in really tweaking and tuning that. So the only kind of tweaking we did here, also in the message processor, was some more caching to make sure we weren't hitting the database every single time we needed a piece of data. So we'd cache things for like, maybe 5 seconds, maybe an hour, depending on what kind of data it was. And then we weren't thrashing the database, and that really helped this perform faster. We also, as part of this testing, both the website and the message processor, we tried different scenarios. Let's try 5 mediums and see how that runs. Let's try 3 smalls or 10 smalls. In the end, we came up with 3 medium, did the job pretty well, and was fairly inexpensive, and that's where we are today. So it really hasn't changed since then, coming from 250 all the way up to 2,000 devices and still performing, meeting their expectations.
What did they have on their old system before you guys started working?
As a number of devices?
Yeah. You said
Was
250
it
on your new
2,000? Yeah, it was around 2,000.
Running really slow.
Right. So it totally choked at 2,000. And ours is still humming, plenty of headroom. Yeah, that's about it.
Okay, so obviously anytime you start an endeavor like this, you're gonna go left when you should have turned right. You'll make some poor choices, obviously. We had a couple of those. And so we're willing to share our mistakes with you guys so you don't have to repeat them. By far, the biggest lesson learned, I'm not sure if Vince made the point yet, that when you're working on an Internet of Things project, it's all about the hardware, right? So the biggest lesson learned is just trying to understand the complexity of the communication, the kind of data that comes in from the hardware. So to give you kind of a snapshot of what I'm talking about, there was a whole device registration process we had to come up with. We were getting all kinds of edge case events, like battery events and those kind of statusing events. The hardware actually uses a fire and forget protocol, which basically means that when they send a message, when the device sends a message, it doesn't know if anything received that message. So the way it compensates for that is it sends it again. And it still doesn't know that it received the message, so it sends it again. And then it sends it again, sends it again, and sends it again, until it gets something new to say, and then it starts reporting that one over and over again. So we had a massive amount of message duplication. Actually, kind of incidentally, we did some metrics, and we found that only 30% of the messages going through the queue were actually even useful. But yeah, that's still stuff we have to process. From the devices, instead of getting like a discrete event for every time something happens, we were just getting like counts over time. So we had to do calculations and aggregate the data over time, very complex. We had, like I mentioned, lots of message duplication. There was the possibility of getting messages out of sequence, which, when you're dealing with counts, is a big problem, right? Because how do you know when that particular count applies? And all the while, dealing with all those issues we had to support, in order to be able to scale, we had to support concurrency. And it was actually those issues that really prevented the old system from being able to scale horizontally. So that was quite the challenge. And kind of incidentally, we didn't really even find out about most of these issues until we were in the pilot, in the beta. So that was quite a surprise on us. So what we thought was going to be really simple, right? We thought we were just going to have some straight line processing, very simple. You know, we get a message in from the device, we decode it, turn it into something else, put it on the queue, and throw it in the database. Ended up looking like this. Very complex. So taking what we learned about how to work with the hardware, we can now start rethinking some of the architectural decisions we made. So first example would be to think about some of the more robust PaaS options in Azure. As an example, the message processor is being hosted currently in a Azure website web job. So web jobs were very attractive to us at the time because it's trivial to get a web job up and running, processing messages from a queue. However, you don't really have a lot of options as far as, with scaling, you're tied to scale with the website. You can't do a lot of concurrency within the process. There are a lot of limitations there. So kind of a retooling to the architecture might be, let's think about worker roles. Another example is the storage queues. So there's another alternate technology in Azure called Service Bus. And Service Bus could actually solve all the problems we had with dealing with concurrency and how to deal with counts and things like that. Because Service Bus has a feature, filtered subscriptions, so we can basically get messages from a particular sensor to a particular processor and achieve scale that way. So a lot of different options. I think the point is that Azure, and actually Amazon as well, any cloud provider, now has kind of a robust ecosystem with a lot of different alternatives to solve your kind of architectural needs. So definitely think about the needs of your system. And remember, it's all about the hardware. Think about how the hardware communicates, what kind of scale you need. We also learned that not everything works as advertised. So again, with those web jobs, Azure has this feature called deployment slots, where you can have a staging deployment and then a production deployment, and then push one button and they switch, so your staging becomes production, production becomes staging. Works great. It's supposed to do some configuration transforms and things like that when you switch. Those were not working at all with web jobs. I will say though, web jobs, I'm not sure if they're out of preview yet. They are?
Mm-hmm.
Okay. Well,
Today.
Today?
Today.
Today they are out of preview. Interesting. So at the time, they were a preview feature. They were very attractive to us, so we went ahead and used them in production. But we found that there were some kind of headaches that we had to overcome there. Next thing we learned was the importance of bulletproofing your app. And obviously this applies in general, but it's especially important, I think, in the cloud when you have to handle massive scale. You want to make sure in a platform as a service environment that you're handling graceful shutdowns. So unlike a virtual machine or a physical server, the cloud service provider at any time can decide, I'm just going to bring your service down over here, move it over here to this other box, and bring it up there. They do that for a variety of reasons, and it's actually a good thing they do that. They do that to maintain the health of your deployment and also just the overall data center. But if your application doesn't handle that, well, then you're going to have issues. Also, the failover. So think about a fallback to your database or really any data store or service that you're depending on. You can scale horizontally your processing, But if it's dependent on some database that doesn't scale, well, you have a single point of failure. So watch out for that. And we also learned about voting for supportability. And the biggest lesson here was, okay, so we're processing thousands and thousands and thousands of messages an hour, right? And we had so many different edge cases that we caught errors that the error log was completely impossible to digest. You just could make no sense of it. So it really required us to really think deeply about what we're going to classify as an error, how we can handle errors before just logging it as an error and trying to deal with it later. Because if you have massive throughput, you're just going to be completely overwhelmed with those trying to look through a log and parse that. So think about supportability, your instrumentation, and we actually made use of the Visual Studio Online App Insights a little bit to get a little bit of diagnostics about the application too.
So this is the next generation. This isn't done. It's still in production. In fact, the old one is still in production, and they're slowly moving customers over to the new platform. I want to drive that car someday. But some of the things we wanted to do with the new version, as I mentioned, a significant rewrite of that message processor. And we've already made pretty good dent in that. I'd say we're over halfway there, actually. To give you some hints about that, some things we've done are, instead of, as we process a message and we need to validate it and make sure all the data is good, we don't hit the database and read all that data now. We're caching as much as possible. Almost everything is in cache. And then, instead of currently, when we're done writing everything to the database with each message, no. We take that data, and instead of writing it directly to the database, we just put it over in another queue for something else to do. And then another job pulls like 1,000 of those off the queue and then does big bulk writes to the database. So now, whereas our original message processor we came up with would do anywhere on the order of maybe 6 to 8 transactions per message it processed, the new one actually does, or will, when we're completely done with it, will do far fewer than 1 transaction per. In fact, the average will be 0, because all the work will be deferred, either cached or queued for a bulk write. So where we are right now in this, our initial throughput was around 20,000 messages per hour. After maybe a month or so of tweaks, we got that up to around about 70,000 messages per hour. And then as of yesterday, we just ran our most recent version. We're now around 150,000 messages per hour. And we're, like I said, we're over halfway there, but we still haven't hit some of those big targets. We're still multiple transactions per message. When we get to 0, I can't wait to see where that number goes, but it's going to be huge. So significant work there. Also on the hardware side. So we mentioned it's all about the hardware. In this particular case, and actually in all these IoT apps we've worked on, we've not had any say in the design of the hardware. Another case in point here. So all these weird artifacts that Nick talked about, that fire and forget and keep sending duplicate messages, sounds pretty ridiculous. We might have wanted to say something about that if we saw that early on. We didn't. But now our client is working with us to come up with some new requirements for a next-gen version of the hardware. So the new version will send discrete messages. I had an event and it happened at this time. So that's a nice step. Message delivery will be improved, so get rid of that fire and forget. That should eliminate our duplicates. Also, the gateways will no longer require an IP address. They'll actually be able to make a call and drop it directly onto the queue. So get rid of that gateway server VM, don't even need it anymore. So that'll be nice. Now if you think about it though, we're coming up with some next generation hardware, which is great. However, do you think they're going to go back to all their old customers and reinstall new hardware for all those? Heck no. I mean, by that time they'll probably be on the order of 3,000 to 5,000 devices to deal with. So instead, we're going to have to stand up some new infrastructure for the new hardware and leave the old infrastructure in place. Obviously, we'll design it in such a way that, maybe the front pieces will be different, but they'll all funnel through the same process in the end, something like that. But we will have to support two different sources of data. Okay, so this is a summary, and we'll get into some questions here. Basically, this is a big cloud solution we're talking about here. Talking about an IoT app. The cloud isn't going away anytime soon. We're seeing cloud adoption going up big time. Microsoft just had a big event today, and they said their year-to-year growth is like 198%. I guess they didn't want to round up. So it's growing big time. And they're not the only ones growing, right? All the other providers are growing too. IoT apps, you heard the numbers from Nick. So these things are growing like wildfire. Expect, what is it, 26 million in 5 years, basically?
Billion.
What? Did you hear that ominous voice? Billion. So these things are trending up. And again, we've done this a few times. The cloud is the ideal platform for these. It makes total sense. If you tried to do this with your company's in-house infrastructure and you sold your product to 5 friends, and those friends thought it was pretty cool, and they sold it to 5 friends, within a few generations, you're starting to go procure some new hardware. How long does it take your companies to procure hardware? Typically, that's a many week, if not many month thing, just to get some daggone boxes in the closet over there. In the cloud, that's a piece of cake. We can spin up new servers and whatever we need instantly with a few clicks. Piece of cake. So the cloud makes it very easy to scale these up. And then what if 3 months from now, Apple comes out with their iWatch and yours just tanks? What do? You just turn it down, But you're not paying for all that hardware if you were doing it in your own data center. You're not paying for all that. Wouldn't that stink if someone trumped your product and then you had all this hardware sitting there idle? In the cloud, you don't worry about that. You just turn it off, turn it down. So we've done a few of these. This one's compliance tracking. Another one was compliance tracking for a construction company. So the construction company had to place these devices around that kept track of dust and volume. So in sensitive areas, maybe near a school or a hospital or whatever, they need to make sure the dust level didn't go too high, the volume didn't go too high, or out of compliance, fine. So again, hardware that we had nothing to do with, and hardware sending those messages up to a server. We put it on a queue. We pull the events off the queue, process them. Very, very similar workflow. Presented on a website. Very similar. Another one with, you know how nurses push the carts through the hospital and they have all those devices on there, blood pressure, little tablets to get data or whatever. Several different devices on there. A whole hospital system was having trouble with their hardware, maybe the battery going dead or something going wrong with it, and the nurse might be at a patient trying to do the nurse's job and hardware was dead. And then that's a big workflow to try to get someone out there to fix it, try to get that nurse back to work. So they instrumented those devices, put sensors on those that detected those sort of fault conditions and post all that data up to the internet. Similar workflow. Throw the data on a queue, got a processor, put it in a database, report on it, website. One other thing that's typical with these, notifications. So sending emails out in bulk, pretty common. Also push notifications if you need to alert someone on a device. And again, similar infrastructure across these apps. IoT is getting big, so you should have heard something in the news about this if you read any big journal, plenty of articles about it. But the providers are now coming out with IoT-specific services in the cloud, So Azure announced some months ago, at least maybe 3 or 4 months ago, that they're coming out with a dedicated service called Event Hubs. So with Event Hubs, you post messages, you post events up to the hub, and it allows you to process millions of events per second. That's a lot. That's huge throughput. And then in your event, you just process it and put it away however you'd like. So, pretty cool stuff. Okay, that's about it. Now, we do have a few minutes for questions. So, yes?
What's your typical data retention or something like yes? For the compliance? I mean, are you looking like, I just want to see 3 months of data, 6 months, I'm looking at years worth of data?
So the initial answer was, well, of course we want it forever. And then we talked about, exactly, then we talked about, remember that problem you used to have? Yeah, let's not go there again, right? So we, and actually our sponsor who we work with, our product owner, he gets it. So basically, he told them, look, you don't want to go past a year. And we are working on putting the processes in place so that after a year, we're archiving off to cheap storage. So we're putting that in place. Not there yet, but it's only 4 or 5 months old now anyway. And then we are also changing our reports so that we can summarize that data up and aggregate it. So our reports run on aggregated data, so it's like data mart type situation, and are umpteen times faster than they used to be.
So it seems like the Internet of Things could make human lives better. So like Nest will turn your thermostat down. Have you offered them like a 100% compliant solution where you're not dinging the people for forgetting to do that? They stand up and it makes the computer lock for them so that they don't have to worry about it.
So just keep in mind that was kind of like a theoretical problem case.
Very contrived.
So in this particular problem domain that they had, it really would have been impossible to come up with something like that. Certainly if you can make that work, I'm sure no one would be unhappy with that. But there's always going to be room for having Internet of Things devices just kind of informing you of how you live, how you work, the world. Think about those ocean buoys, things like that. They can't control the weather; they can only report on the weather. So there's always going to be room for these kind of systems.
But still, don't forget to lock your computer. It's just.
What were your costs like to do the load testing on the cloud?
That's tough to answer. So I can tell you, we've done lots of load testing in like the last billing cycle. And to do that, we scaled up to, as per their goals, so where do you want to be in a year from now, which is what we're targeting. So this is on the order of 5,000 devices. We scaled up the database with that huge, we're around 170 some million rows of events in the database, plus all the supporting data. We have scaled up the database to the size we think is appropriate. We've scaled out our services to match that, and then we try to crush it. And those numbers you saw I know it wasn't very meaningful data, but those actually were a real test. And what we have seen is their monthly bill in our test environment where we're doing all this testing. What I can tell you is it's about 3 times the bill that they have in production. Their production bill currently is significantly less than their bill was in the old Amazon big VM scenario. And where we are in test is about 3 times that. So we would expect that in a year, if their growth goes as they are tracking, and it really is, it's more than linear. I wouldn't say it's exponential, but it's trending up like that. So their growth should be there in another 6 months or so. Yes?
I got a quick question. You guys covered like a lot of the aspects around the technical stuff. I'm not super technical, I just wanted to throw this out there, but like do you see security concerns surrounding these Internet of Things? Like, because they're all going to go through the air, right? They're all wireless. You're not dragging Ethernet cords to these devices. So, how do you go ahead and address that aspect? You're talking about the cloud, so I'm assuming that's whole internet. Your thermostat's talking to some server somewhere. People are intercepting your data. Now I know who's logging in, who's not logging in. It's a little bit asymmetric, but do you guys see an industry for security console even on these as Internet of Things start taking off, right?
So interestingly, for this, for the hardware that they have right now, there really wasn't much of a security concern that the clients had at the time initially. But the next edition of the hardware, and actually I think they're talking about doing a firmware update to the existing hardware to where they start encrypting the data. That is probably an area that's open for a lot of debate and discussion, and I know that there is kind of a standards board that's trying to come together and come up with some really high-level standards on how to address some of those things, but this is kind of such a new industry that it hasn't really been formalized a lot right now.
Just for some context though, when you're talking about your original case, I mean I understand if it's under NDA, but you're tracking whether or not people are logged into their workstation or logged out. Is that the core idea behind this device, or?
That is the contrived scenario. It's like that. But one point is, it's not sensitive data, so they're not worried about it. They're not stressed over it. If it were posting up your watch was posting your pulse and your steps, that's your personal sensitive information. Well, not really. And that's the case here too. So the data is not sensitive. There's a couple of security concerns. What if they get to your database? Well, they can't. They'd have to get onto one of our physical machines to do that because it's all blocked. It's locked to certain IP addresses. And then there's the login and all that kind of stuff. Then there's the website. Well, if someone wants to hop on and see what my compliance is, okay, go for it. But it's a secure website just as much as anything else is. It's all HTTPS. You got to log in. We're destroying cookies after, all that typical web stuff. So feel pretty good about that.
The security side, free data is good, but it's not a small stretch of imagination to think that I'm from Nationwide, we're an insurance company, a financial company. Sure, right now you got the telematics, it tracks how you drive, you can adjust your premiums to that. But how soon before it becomes like a Fitbit? Hey, you're not registered. I noticed Nick didn't register 10,000 steps today, so I'm gonna dock his health insurance. I'm gonna upcharge a premium. He's not as healthy as everybody.
You heard it here.
No, that's a health insurance. So the point is, do we have these security concerns over the data that you're just sending out over the air? I mean, it's got to be.
We should be concerned in those kind of sensitive scenarios. And so as Nick hinted at, there is an industry consortium formed now and growing to address things like that. But the kind of things we're typically seeing out there now aren't that sort of sensitive scenario.